Hello everyone, and welcome back to another CIV 398 assignment tutorial. In this tutorial, we're going to be covering question 3, which is a very difficult question unless you use computers. So of course, we're going to use computers, make our life easy, and hopefully you guys can learn a little something that you can take on to other courses, stuff like that. So, the question itself, very simple, straightforward. It says, consider the vectors x, which is 2, 4, 3. So we have all the components of x, and y, which is y1, y2, and y3. So we know nothing about y. And it wants us to determine the components of y such that, and it gives us 3 different conditions. First is the Euclidean norm of vector y is the square root of 41. The second is the Euclidean distance between vectors x and y is the square root of 14. And finally, the magnitude of the orthogonal projection of of y on x, I'll always get those confused, is 28 divided by the square root of 29. So, main thing here, we got to figure out y. And as we can see, there's y1, y2, and y3. So in the end, we're going to have 3 unknowns. So, quick summary, vector y has 3 components, or 3 unknowns. Therefore, we know that we're going to need 3 equations to solve this system of equations. So what we're going to do is we're going to take what we already know from those conditions and apply them into equations. So the first one, we were given the Euclidean norm of vector y. So if we were to write this as a formula, we have the Euclidean norm of y, which is equal to y1 squared plus y2 squared plus y3 squared, all square rooted, and this is equal to the square root of 41. So this is already known. That's actually really nice for us. So we actually have our first equation. We can move on and say, well, we also were given information about the Euclidean distance between vectors x and y. So if we expand this out, it's a big long formula. If I try and say it, I'm just going to mess up and sound like an ass, so I'm not going to. But all of that mush in there is equal to the square root of 14. And although it looks like we have 6 unknowns, we actually only have 3 because x1, x2, and x3, we already know they're already defined. So there's equation 2. And then in the end, we have our third equation, which is the projection y onto x. So this can be expanded out as x dot y divided by the magnitude of x. And we already know the components x1, x2, and x3. As well, since we know those components, we can also find the norm of x on the bottom there. And we know that this is going to be equal to 28 divided by the square root of 29. So we have our 3 unknowns, y1, y2, and y3, and we have 3 equations, and in each one of those equations we have y1, y2, and y3. So we can actually solve this system of equations. However, as you guys will quickly see, we have a problem, because even though we have 3 equations and 3 unknowns, well, these equations are not linear. So all those matrix methods that you guys learned in Math 102, you know, with defining the matrix, using Gauss elimination, all that stuff, well, that doesn't really work when it's nonlinear. And that makes sense because Math 102 was linear algebra, and this is nonlinear algebra. So solving these equations by hand, well, in essence, would suck mega ass. So what we're going to have to do is use a computer program such as MATLAB or Mathematica to solve these equations. Now, although I love MATLAB, and I'll always love MATLAB, Mathematica, I must admit, is better for this course because it helps us solve differential equations much more easily than MATLAB would. So because of that, we're going to solve this problem and do a quick little Mathematica tutorial on how to solve these equations. So let's jump on over to Mathematica. All right, guys, welcome to Mathematica. So I got 2 things going on my screen. On the left side here, this big empty page, this is Mathematica. So it doesn't look the prettiest, but it's very powerful. It'll help you guys a lot in this course. So I will show you how we use this to type in our commands as well as receive our outputs. Now on the right side, what I did is I created a little Word document to show you what exactly we're trying to solve. So right now, this is what you guys will try and solve in the assignments. We have our vector x, and then we also have our vector y, and y has the 3 unknowns that we're trying to solve for. Now, we have 3 equations to solve for those 3 unknowns, which are the Euclidean norm, Euclidean distance, as well as a projection. Now, if I were to solve this directly, I'd just give you guys the answer to the assignment. That's not really the goal of these tutorials, so what I'm going to do is I'm going to switch it up a bit so you guys can still learn exactly what to do with Mathematica without me giving you guys the answer. So very simply, what I'm going to do is instead of solving for y3, I'm going to say I already know that y3 is equal to 5. And if I know y3 is equal to 5, well then I only need 2 equations to solve for y1 and y2. So I'm going to skip this third projection equation, and I'm going to focus on equations 1 and 2 to solve for unknown variables y1 and y2. So for you guys, it'll be the exact same procedure, except you're going to include that unknown variable y3, and in turn include equation 3. So if we go to Mathematica, all we have to do is really define our vectors, and then we can solve them. It's actually pretty simple. So in Mathematica, to define something, it's the same as MATLAB, where we go x is equal to, and then to define a vector, we use the squiggle brackets, just like that. And we already know that x is equal to 2, 4, 3. And to separate the entries, we use a comma. So it's going to look just like this, where we have 2, 4, 3. So that's x. Now if we go down, we can go y is equal to, and again we're using squiggle brackets because it's a vector, but we don't know the first two components. So what I'm going to put in Mathematica is I'm just going to put y1, y2, and of course I know that the last entry is 5. And as you guys will see real quick, Mathematica automatically highlights y1 and y2 in blue, meaning that they're currently not defined. And if this was the case in MATLAB, you'd have a problem right away. You'd have to use symbolic stuff to kind of get around it. But luckily for us, we're in Mathematica. This won't create a problem right now. If I were to return the vector y, it's just going to say it's y1, y2, and 5. So it won't tell us anything. It won't solve anything for us. So in order to solve the equations, we're going to use a special function called solve. And what solve is it's going to take two inputs, and then it's going to solve our equations. So in order to use solve, oops, I always mess up the square and the squiggle brackets. Again, we're going to have two inputs, so we're going to have a squiggle bracket and a squiggle bracket. And what we're going to do is we're going to fill in each one of these squiggle brackets, and it'll solve our equation. So inside the first squiggle bracket here, we're going to put the equations. And inside the second squiggle bracket, we're going to put the parameters that which we want to solve for. So if I wanted to, right in here, I can input the square root of y1 squared plus the plus y2 squared, blah, 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 blah. However, it's going to get really messy. When I try and input all of this into this little squiggle bracket, and then I got to follow it up with all of this, of course, it's going to look real bad. So what I like to do personally is I like to predefine the function so that it just makes things a little bit easier. So looking at equation 1, we know it's going to be the square root of y1 squared plus y2 squared plus y3 squared. So if you guys really want and make it painful for yourselves, you guys can go the square root of y1 squared and then blah, 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 blah. However, we have to realize that Mathematica is actually pretty smart. And it has predefined functions for all these things that we're interested in. So it actually has the Euclidean norm built right in. And to call that function, we just type in norm and square brackets. Oops. Again, I'll always get the squiggle and square brackets mixed up. So in order to find the norm of something, we just type in norm, and remember it has to have a capital N, and then within the square brackets you want to take what vector you're taking the norm of. So in this case, we're taking the norm of y. And I come down, oops. I come down and I can say, well, we also have equation 2, which is the Euclidean distance. Now, if you guys ever tried Euclidean distance in MATLAB, there is not a predefined function. In MATLAB, we have to kind of modify it a little bit. However, luckily for us, Mathematica does have a predefined function for Euclidean distance. The only drawback is the name of that function really sucks. It's exactly what it is, and it's Euclidean distance. So I'm going to have to type in Euclidean distance. Luckily for us, Mathematica says, oh, I think you're trying to say this, so I can click on it. It gives us our new function. So within the Euclidean distance, we have to define the two vectors we're trying to determine the Euclidean distance of. So in this case, we have x, and we have y. So I just go x comma y. So now I got equation 1 is equal to the norm of y, which is exactly what we have right here. And then equation 2 is the Euclidean distance of x and y, which is this right here. So far, so good. And what you guys will do is you guys will have an equation 3, which you guys will input as the dot product of x and y divided by the norm of x. So I'm sure that you guys can do that on yourself. It's not that hard. You guys will be just fine. So really quick, one thing that I don't like is when I submit the function for the output and all this crap appears. I like to suppress things so that they don't appear. So just like MATLAB, I can suppress these things using the semicolon, and that way when I solve the function, it won't tell us what x is, what y is, what equation 1 is, and so on and so on. It'll just tell us the answer that we want. So with the equations defined, as well as the parameters defined, I can go into my solve function and I can start inputting which equations I want to solve. So of course we want to solve equation 1, and we have to say that equation 1 is equal to something. And we're already given that equation 1 is equal to the square root of 41. All right, perfect. What I can do now is I can go comma, equation 2 is equal to, and in this case, it's going to be the square root of 14. So in those first squiggle brackets, like I said, we're telling Mathematica what equations we want to solve. So all I did is I went equation 1, which is the norm of y, is equal to the square root of 41. That's basically exactly this statement over here in the Word document. And I went, okay, there's a second equation, so I went comma, equation 2 is equal to the square root of 14, and since equation 2 is the Euclidean distance of x and y, that's the exact same as inputting this right here. Now, the last thing we're going to have to input in the second squiggle bracket is the parameters that we're trying to solve for. So as you guys know, we're trying to solve for y1 and y2. So all I have to do is put y1, y2, and we're good to go. So what Mathematica now realizes is that we have two equations and we're solving two unknowns. We're good to go. So all you have to do now is hold shift and press enter, and that'll execute the code. So if I press that right here, what I see is our solution right here. We have y1 is equal to this, and y2 is equal to this, and this is a solution. Now a lot of you guys are going to go, oh, wait, Clayton, what's going on down here? Why is there a second one? Well, that's the thing about nonlinear equations, is sometimes there's more than one solution. So in this case, there's actually a second solution that also satisfies these parameters, and that's this one right here. Now, in the assignment, we just ask you for a single solution, so all you guys are going to have to do is list one of the solutions that works. You're good to go. And if you guys want to verify that the solution works, it's pretty simple. All you have to do is take this value as y1, take this value as y2, and just check the Euclidean norm, the Euclidean distance to make sure that it's good to go. So that's how you guys do it. Again, all you guys are going to have to do is you guys are going to have to input that third equation. So up here, you're going to have to say, okay, well, instead of 5, we got y3. We're going to have to say equation 3 is equal to ... And then down here, we're going to have to specify equation 3 is equal to ... And then we're also solving for y3. So you guys should be able to do this nice and easy now. Hopefully this clears some things up with Mathematica. I know it's a little bit different than what you guys are probably used to with MATLAB, but it's very powerful. And the reason why we use Mathematica will become much more clear when we start to solve differential equations. So thank you guys so much for listening. This concludes question number 3. I will see you guys in question number 4.